And this is actually something that is very, very similar. These are basically drawings that are very similar to your system drawings, but we use them for a different purpose. And this is going to be talking about flowcharts. And flowcharts we're usually going to use in the context of showing how software works, right? It's very, you could copy and paste your entire code into one of your design documents, and really that doesn't tell anyone who is either not familiar with the programming language and or does not have the time to go through line by line and read all of your code, how your code works. So instead, what you want to do is use flowcharts in a similar manner to the system design diagrams, and where it shows functionally how your program works. So, a flowchart is a diagram that shows a work process, something that occurs step by step, right? Like I said, we're mainly going to use them in describing software, but you could use this to describe how your payload works, right? Maybe there's, I could make a flow chart that explains how we fill and launch the balloon and then do the recovery. But like I said, I want to cover the stuff that's going to allow you to accurately document your software. You can use it in other fields, and just like the system diagrams, there's different levels of how simple and how technical they can be. They can be super detailed, or they can just be, a very basic big picture overview of how something works. So a flowchart is a visual representation of a sequence of individual steps, right? It says step by step what happens in the work, what happens in the program, what happens in this process that you're describing. You also use them to demonstrate, is there a decision that is made in part of this process? And like I said, they are very, very useful, not only in describing your software, but it's also very useful for planning out what your software should do. Because you will generally have an idea of, I need to do this X, Y, and Z in my code. But if you just just try and start writing programming code for it, you'll probably forget about things or skip stuff. So it shows how the data flows, and it's going to help you plan out how to write your code. So as a very sort of generic example, well, not a generic example, but a non-software related example, this is, you can write a flowchart for someone getting ready in the morning to go to work or go to school. So they wake up, you get out of bed, you brush your teeth, you figure out, do you smell or not? If you do smell, you go take a shower. If you smell clean already, you don't need to take a shower and you skip that step. Are you hungry in the morning? If you are hungry, you eat breakfast. If not, I'm done. I'm ready to leave, go to work. Right? This is super simple, but you could easily see how this applies to, you could translate this to a programming interface. So you can see that we have a number of different sort of components on this little wake up and go to work flowchart. But of the two types, there are two basic types. I have the single steps, which we would call symbols or blocks, and then I have the connectors, which are the arrows in between them, right? So the symbols basically are where you are taking an action, you're performing a step, you're showing where the data is, it's where I'm storing data. And the connectors are just what is where you're detailing what is the next step, what is the next operation. There are a few sort of pretty commonly used symbols, but by no means should you consider these like, hey, I have to use exactly the symbols, and or these are the only symbols I'll ever use or ever need. So in general, you use these rounded rectangles to indicate the start and stop of either the entire program or the sub-process. You use these rectangles to indicate a single event. You use these diamonds for a decision symbol. So this is where you branch out to a yes or no. Maybe there might be more than two possible. You could have what is a switch statement in a program, you know, A, B, and C. I go these three different paths. And then we have a sub-process, which is, this is very similar to your subsystems in that this is a more complicated series of steps, but within the flow chart that I'm talking about, I want to simplify it, and then I'll go document what happens inside this sub-process in a separate drawing. So if we start with the start and stop, right? This is where you enter a program, but more importantly, it's where you also enter a sub-process, right? If I have a sub-process that which is like a function that I'm calling in my code, I want to show where that starts. I want to, you know, what are the initial conditions that happen? And I also want to show what happens either when my program reaches an endpoint and it just stops, or if this is a sub-process, this would be the step where you return to the main process that had called this sub-process. A key thing to note is basically you should only have one starting point, right? Whenever I call a program, I start from the same spot. I might have different possible stopping points. I could have a decision that, you know, if X is greater than 10, I immediately stop my program. But if I continue, if it is less than 10, I continue on and do other steps, right? So it is possible where you could have multiple stops. But since you always start from the same point, there should be a single starting point. The process symbol. So this is where we want to basically only do like a single step, right? If it was something that was more complicated, we would probably want to use the sub-process symbol, or we would want to divide the step up into multiple blocks. So a good way to think of this is the sort of operation that is a single line of code. I'm incrementing the counter C by 1. I'm reading the value of analog pin A1. An important thing is you should only have a single arrow coming out of these types of blocks, right? Because you are always going to proceed on to the next step. This should not split off and do multiple things coming out of this. You could have multiple ways coming into it, right? Because you could have multiple ways of entering this step, but you're always going to go on to whatever the following step is immediately. If you do need to split, that means you should have one of these. You should have a decision statement. That's where your program is going to do some sort of logical operation. It could be an if statement. It could be, you know, checking the conditions if your loop should continue. And in which case, that is where you can have multiple arrows leaving. And you usually draw this in a way that, you come in on the enter in the top, and then the other corners are where your exit arrows corresponding to the different possible branches are. But one thing that's important is each one of these paths leaving your decision symbol should have a clearly defined condition of when you go on that path. If X is greater than 10, do this. If Y is less than 1, do this, right? There should not just be unlabeled arrows coming out of this where you can't tell when you go down that path. So the subprocesses, like I said, they're similar to the subsystems that we just talked about. This is where you are going to have your complex operations that I want to group together to make a simpler, higher level drawing. But that means somewhere else, at least eventually, I should have another flowchart that details whatever happens inside this block. In that separate flowchart detailing the subprocess, you should have the start and stop blocks that shows, okay, this is where you enter the subprocess. This is what happens. This is the point where it returns basically back to this block with the square inside and goes on to the next step. And a good way to think about these is these are the functions that you call inside of your program. This may be functions that you write yourself, but it could also be library functions, right? When I write a line to the SD card, I'm actually calling a function from the SD card library that does a whole bunch of complicated stuff. Now, for stuff that is like subprocesses from a library, you probably don't need to, document what happens inside that subprocess because you're using a library. It's a predefined sort of thing. But anything where you're writing, you want to detail that somewhere else in your software design. So the arrows, unlike the system diagrams, should always be pointing one way, right? Because a program only goes to the next step. It doesn't go backwards. If you need to return to an earlier point in a program, like a loop, the arrow should still just be a single direction. It should just go back to the beginning of the loop, right? Because that's how the loop actually works in the code. You get to the end of the loop, you go back up to the top, and you check that, that decision point again. You could have, so most of your blocks should be able to have multiple arrows leading into them, right? So for example, the loop function of the Arduino, well, one way an arrow going into that would be from the setup function, right? In an Arduino, as we've talked about previously, as soon as you finish the setup function, you go straight into the loop. But the loop function also goes back to its own start when it finishes, right? So a loop would have two arrows coming into it, one from the setup and one from basically the end of the loop leading back to the beginning of the loop. That being said, like we said before, only the decision points, the diamonds, should have multiple arrows coming out of them, right? Because if you're going to take multiple paths, that means you're having to make some sort of decision on which one of those is occurring. Just as a point of keeping things clear and readable, you generally want to avoid having lines that cross in these flowcharts because that can be ambiguous and unclear and hard to tell what's happening. All right, so designing your flowchart is sort of similar to drawing and designing your system diagrams. You want to think about what is the scope, how detailed is this flow chart going to be? What am I trying to document on this flow chart? You're going to identify all of the tasks. So what do I need to accomplish on this flow chart, and what are the different steps that go into accomplish it? You want to lay out the steps in a logical order. In general, sort of similar to Colleen's slide, those of us who grew up on English and Western style language are used to top to bottom, left to right. So usually your flow charts will follow some sort of design, flow like that. For example, what we showed earlier, you started at the top and you went to the bottom. Once you've drawn all of your flow chart, you want to step through it, go through step by step and see if it makes sense. Verify that you get to the end point and that you've accomplished everything that you wanted to and you should have. Then you want to go back and make sure, hey, is this readable? Especially, is this readable in the size of the document that I'm going to put it in, right? Because one thing that you're going to do with these is you're going to draw these flow charts, and then you're going to include them on like your CDR, your PDR, right? So if you have to shrink it so much to get it to fit on a page where you can't read anything, that means you probably need to break it up, either put things into sub-processes or, break it across pages, which is fine. You just need to show on your diagrams where you leave one diagram and go on to the next, right? So again, since these are very similar, the software is very similar to the system diagrams. So it's probably easiest to use the same software that you're going to use for your system diagrams. This means Visio, Google Drawings, Draw.io. If you are looking for another one, just Google open source Visio alternatives. Find one that you're comfortable with and that you like, right? You're probably going to be exporting those drawings as images and using them in presentations, in your planning documents, in your design documents. So that is it for today.